Okay, guys, this is going to be day 2 of the quadratic formula, and we're going to be focusing on a certain part of the quadratic formula that is called the discriminant. And the discriminant is the b squared minus 4 times a times c that is located underneath the square root sign. So you can see it right there. When we are analyzing the discriminant, we are using that information to determine the number and type of solutions. So right here. So we use this to determine how many, or I'll just use the terminologies they use here, number and type of solutions. And we have actually already talked about this a little bit, but I'll review it quickly. When you graph your quadratic, for this example, if it hits in 2 places, that means that there are 2 real solutions. And the circumstances where there are 2 real solutions is when what's inside the square root sign ends up being a positive number. Because, and I'll use a quick example here, let's say x equals 3 plus or minus the square root of 14 over 2. If you look here, 14 is definitely greater than 0. And if you have a number in there, that means that you're going to do plus and minus. So that's what gives you 2 real solutions. The next option is, let's say when you plug in your numbers for a, b, and c, let's say that what's inside the square root sign becomes 0. So I'm going to do a similar example, but let's say that's a 0. Well, if it's 0, then the plus or minus here, you don't need to do a positive and a negative. So that means that you're only going to have one real solution. And that's a circumstance, as you recall, it's when your parabola hits the x-axis in exactly one place. And then the last option is over here, and that is when it doesn't even hit the x-axis. And we know in that case it has 2 imaginary solutions. And in order for us to talk about something being imaginary, we know that I is going to come in, and we recall that I is equal to the square root of -1. And that's the case where, and I'll use once again just making up a similar example. And in this case, I'm going to make what's inside the square root sign a negative number. So if this is negative, that means it's less than 0. Okay? And if it equals 0, it's this option right here. And then you have that one. So in order to figure this out, I'm going to a new slide. I'm trying to go to a new slide. Here we go. So now we are going to analyze the discriminant, just like we talked about on the previous page. And so for each of these, I need to list what A, B, and C is. So A for this is +1, B is -6, and C is 10. Here, A, B, and C, A, B, and C. A is 1, B is -6, C is 9, A is 1, B is -6, C is 8. Now, The discriminant, remember, is b squared minus 4ac. When we are looking at the discriminant, there is no square root sign. The discriminant is just the part that's inside. So down here, b squared, negative 6 minus 4 times a times c. B squared here, negative 6 squared minus 4 times a times c, and b squared, negative 6 squared minus 4 times a times c. Excuse me, this should have a squared. So this becomes 36, and 36 minus 4 times 10, so that's minus 40. That's negative 4. The second one is 36 minus, and 4 times 9 is 36, so that equals 0. And here this is 36 minus, and 4 times 8 is 32, so that's positive 4. So because it's greater than 0, that means there are two real solutions. Because it equals 0, that's one real solution. And because it's negative 4, it is 2 imaginary. And that's all you need to do when you're analyzing the discriminant. Now I want you guys to try these down here. And just like before, I'm going to pause while you do the work. And when you come back, the worked out solutions will be there for you to capture, or check, I should say. So there are your solutions, guys. Make sure that you make corrections to your work, and your corrected work should be in your notes. So the next thing we're going to do is using what we know about analyzing the discriminant to help figure out what we would do to write an equation that would give us that type of discriminant. So if we look at example 5, it says find some integer values for a and c. So we're going to come up with a number for a and for c so that it only has one real solution. So for it to be one real solution, then we know that the discriminant has to equal 0. We know that b is a negative 4. So I'm going to just plug in a negative 4 for b. And I get 16 minus 4ac equals 0. And if I add 4ac to both sides, I get that 16 equals 4 times a times c. If I divide both sides by 4, I end up that 4 is equal to a times c, which basically means any numbers at all that when I multiply them together to equal 4 are okay for a and c. So I could make a equal 2 and b equal 2. That's one option. Or I might make a equal to 4. And I don't mean to say b, that should be c. So a could be 4 and c could be 1, because 2 times 2 is 4, 4 times 1 is 4. So there are more, there's more than one correct answer. One correct answer would be 2x squared minus 4x plus 2 equals c. So I want you guys to try down here, and then I'm going to pause, and when you come back, you'll get to see the worked out answer. So there you go, guys, down here. Because it's two real solutions, we know that the discriminant needs to be greater than 0. So this one's a little bit different because I used a greater than sign instead of the equal sign, but everything else is the same. And I get to a point where I just need to pick two numbers that when I multiply them together, they're greater than 9 over 4. So I picked 2 and 3 because 2 and 3, 2 times 3 is 6, and that's clearly greater than 9 over 4. And then I wrote my equation with a 2 in for the A and a 3 in for the C. So now let's look at a summary that some of this is from the fall and some of it is what we're studying now. And it's all the different ways for solving quadratic equations. So remember that we used graphing initially, and we used our calculator mostly. And when we did that, that's when you looked for the intercepts. So we did that on your calculator. Using square roots was when you took the square root of both sides. Factoring, remember, was when you did this. Completing the square is when you needed to figure out what number that was added to both sides. And then the quadratic formula, which we've been studying so far since returning from break. What's nice here is that this column tells us when to use each kind. So I think it's important for you to hold on to this information. You should put this in your notes so that you really know when to use each one. So graphing, if where it hits on the axis are reasonable numbers and you're allowed to use graphing, you can do that. Using square roots, obviously you want to use that when it appears that you can take the square root of both sides. Factoring, you know that not everything can be factored easily, even if you use the X factor method. But if it can be factored easily, that's a great way to find your solutions. Completing the square is a little bit more complex. And then, of course, the quadratic formula, which can be used for any quadratic equation. So I'm just going to write it here so that you see it one more time. And it's going to be really important that you have it written on the top of any work that you do with the formula, because the last thing you want to do is do all the calculations and realize that you didn't have your formula written down correctly. So make sure you have that in your notes. So the last thing we're going to look at with using the quadratic formula are solving real life problems. And there's two different situations that we're going to look at here. The first is if the object is dropped. So some of you maybe even had to do like an egg drop contest where you try to protect your egg and drop it from the second story window to see if it will break. So when an object is dropped, you're not throwing it, you're not giving it any energy, only gravity is working on it. And so that is a different circumstance. When an object is launched or thrown, I think you can agree that there's some energy put in to the object. So let's look at these two because there's some things that are in common and some things that are not in both of them. So H stands for height. And the height of an object is related to a couple of different things. T is the time it is in the air. V with the little zero down below means like at the very beginning. So we call that initial velocity. And velocity is like speed, you guys. Okay? And then h sub 0 is the initial height. And you might even want to think of it as being the beginning velocity, beginning height. So let's look at the examples with the photos that they have, okay? So here, up here, this is where somebody is using a bow and arrow. So there is no, like you're not putting any velocity into the object, and it is going horizontally. This one, you're hitting the golf ball. And this one is a little bit different. We'll talk about that later. And that's where the ball is coming down. So you're actually bringing it down. So these two equations are really important, and I've got them copied on the next pages. And let's look at how we can apply them. So we have example 6. Modeling a launched object. So remember, launched. See, launched, launched. So a juggler tosses a ball into the air. The ball leaves the juggler's hand 4 feet above the ground. So that would be h sub 0, because that's the beginning height. So 4 feet is my beginning height. In fact, I'll cross that off just so you can see 4 feet above the ground. It has an initial velocity. So initial velocity, that's v sub 0, is 30. And I'll put h sub 0 up here. I'll fix that just a little bit. Tidy that up a little bit. So that equals 4. And my initial velocity is 30. The juggler catches the ball when it falls back to a height of 3 feet. So back, that's the final height, is 3. And if they're saying how long is the ball in the air, that must mean we have no idea what t is. So let me put this together in my equation. So 3 is my h equals negative 16 t squared plus my initial velocity is 30 times t, just like what I have up there, plus my initial height, which is 4. So now, you guys, as long as I put it in standard form by subtracting 3 from both sides, I end up with an equation that I can use the quadratic formula in. So this is what A equals negative 16, B equals 30, C equals 1. And I can do the quadratic formula, which I'm going to write out. So x equals negative 30 plus or minus the square root of 30 squared minus 4 times negative 16 times 1 all over 2 times negative 16. So x equals negative 30 plus or minus, that is 900 plus 64 over negative 32. And I don't have my calculator right here, you guys, but if I were to do it, in fact, I'm going to pause and get those two answers so I can tell you what the answer is. So x equals negative 30 plus or minus the square root of, it's about 31.05 over negative 32. And so now what I'm going to do is take, the square root of 964 is the 31.05. So I should not have drawn the square root sign. That's okay. So it's about 31.04. So I could have either negative 61.04 over negative 32. That's if they're both negative. Or I could have 1.04 over negative 32. And notice I'm using x, but x is really the same as t. So x equals t in this, for this problem. Because we're used to seeing x's for this value. If I were to do this, so let me find these two values here. So I've got 61.04, a negative divided by a negative is going to tell me that that number here is about 1.9 seconds. And if I do the other one, this is going to give me negative 0.0325 seconds. And because we're saying how long is the ball in the air, I hope you can tell that it should be that one, because a ball can't be in the air for a negative amount of seconds. So you're usually going to end up with one that works and one that would not make sense in that scenario. And it makes it very obvious which one you should choose. So now I want you to try one. And I've brought the two formulas right here for you. This is the example from the previous page, but we are going to use some of it. Okay? Because they're saying, what if the ball leaves the juggler's hand with an initial velocity of 40 feet per second? How long is the ball in the air? So once again, it's still going to be launched. So that's your equation. And initial velocity is going to be 40. And you should be able to find your height at the end, and your initial height is located on this page up in the problem. And then I want you to work it out like on the previous page. And I'm going to pause and do it so when you come back, you can see the worked out solution. So there you go, guys. I've worked it out for you. And like on the previous page, the answer here is about 2.525 seconds, because the negative seconds can't work. Okay, so here, remember, I'll just fill it in. The ending height was 3 from the problem right up above, and the initial height was 4 feet, because that's when it left the juggler's hand. So that's how I got this equation. And then I used the quadratic formula to get me to here. And that's it.